Hi all, in this video we will learn about hierarchical clustering. Hierarchical clustering. There are two approaches to hierarchical clustering. One is bottom-up approach, agglomerative clustering. The other one is a top-down approach, that is the divisive clustering. Both the methods are using the dissimilarity matrix as input. Here in the bottom-up approach, the most similar groups are merged at each step. Whereas in the top-down approach, the groups are split using different criteria. In this figure, we could see using the single link clustering, let us see how it is grouped. This is the city block distance. Here pairs 1, 3 and 4, 5. They are both distance 1 apart. So we will be merging 1, 3 first and then 4, 5 next. This is the dendrogram, the visual representation of the merging. You could see 1 and 3 are merged at first and 4 and 5 are merged because they are distance 1 apart, and after which these two clusters are merged, and the next level is this 2 is merged with this particular cluster. Now agglomerative clustering. This agglomerative clustering, it starts with n groups in which initially there will be one object, and at each of the step we are merging the similar groups, two most similar groups. So we will proceed this until there is only one single group. There are actually three types of agglomerative clustering. So depending on how we are defining the dissimilarity between the groups of objects. The first one is single link. Here in single link clustering, we also call it as a nearest neighbor clustering. The distance between any two groups is defined as the distance between the two closest members of each group. That is, here G and H are the two groups. We are going to define the minimal distance between the two closest members of the each group. For example, here AB are the members of this particular cluster and CD are the members of this particular cluster. And a single link clustering, you can merge if B and C are at a minimal distance. You need not consider A and D as far as a single link is concerned. Moving on to complete link. In complete link clustering, it's also called furthest neighbor clustering. The distance between the two groups is defined as the distance between the two most distant pairs. That is, this group G and H, the distance between the two most distant pairs is considered here. So here again, A, D are at the most distant pairs. A and D are the most distant pairs. So which means within the threshold, both A, B should be within the threshold to C and D. Average link. So for average link, we need to measure the average distance between all the pairs. So average of the distance between all the pairs. Here this n suffix G and n suffix N are the number of elements in groups G and H. Divisive clustering. Here in divisive clustering, you start with the data in a single cluster. Then recursively, we are dividing that cluster into two clusters in a top-down fashion. This picture illustrates both agglomerative and divisive clustering. As far as agglomerative clustering, it begins here. The step 0 starts here. So each of the point is treated as a separate cluster. And in step 1, we are merging A and B. Then step 2, we are merging D and E. And in step 3, we are merging C, D, E. And step 4, finally, all the clusters are merged and formed as a single cluster. Whereas in divisive clustering, the step 0 starts from here, which means we start from a single cluster. So it's step down, yeah, CDE forms a separate cluster, and then in the successive steps, they are dividing, and finally they end up in single cluster, each and every data point as a single cluster. Bayesian hierarchical clustering. So this approach, this is the algorithm representing the Bayesian hierarchical clustering. Initially, each and every data point will be treated as a separate cluster. So n number of points are there. Each of the data point will be treated as a separate cluster. The next step is we need to compute the probability of that particular cluster given the T suffix I specifies the prior information. We are repeating these steps 4 to 8 until all the clusters are merged. So for each of the pair I and j, we need to compute the probability of that D for the two pairs I and j given the prior information of that ij. We need to find the pair of those two clusters with the highest merge probability R suffix ij. So find some pair, find the clusters di and dj, and we need to do that with the highest merge probability of it. And the next step is we are merging that di and dj as a single cluster dk. After merging that di and dj as a single cluster dk, we can delete the two clusters di and dj. We need to repeat these steps until all the clusters are merged. Let us see a problem. Now we are going to perform the hierarchical clustering using a single link and complete link on the data set, and the distance matrix is given. We need to derive the resulting cluster structure. This is the distance matrix. We have 4 points and the distance between each pair is given here. Let us consider this distance matrix. For single link, the distance between two clusters is the shortest distance between a pair of elements from the two clusters. When the distance is 0, there will be 4 separate clusters. When the distance is 1, so there are points P1 and P2 within this threshold. So we can merge P1 and P2 as a single cluster. P3, P4 will be acting as a single cluster, separate clusters. When the distance is 2, from the distance matrix, we can understand that P2 and P3 are at a distance 2. So this P3 can also be merged with this cluster as P2 is here. So P1, P2, P3 will be a single cluster and P4 will be separate now. When the distance is 3, looking at the distance matrix, we can find P3 and P4 are at a distance 3. So this P4 can be merged with this group. Now all the points will form a single cluster P1, P2, P3, P4. So when the distance measured is 3, all the 4 clusters are merged into a single cluster. This is happening with a single link. And the corresponding dendrogram is represented here. This dendrogram shows the visual representation of how the merging is happening. So at a distance 1, we are able to merge P1, P2. At a distance 2, we are able to merge P3 with that group. When the distance is 3, we are able to merge P4 with that group. Next, complete link. This is the distance between two clusters, the longest distance between a pair of elements from the two clusters. Now here, when the distance is 0, there are 4 clusters. When the distance is 1, we are able to merge P1 and P2, fine. When the distance is 2, from the distance matrix, we can find only P3 is within the threshold with P2. And looking at the clusters here, as far as a complete link is concerned, both P1, P2 should be within the threshold to P3. Only then both the clusters could be merged. So that will remain as such. We can't merge as of now. So increasing the distance to 3, again looking at the distance matrix, P3, P4 are at a distance 3. P3 and P4 are at a distance 3. So it is possible that we can merge P3 and P4 and make it as a cluster. So when the distance measure is 4, we need to check whether we will be able to merge these two clusters, but that's not possible because when the distance measure is 4, both P1, P2 should be at a distance 4 with these 2 points. So that's complete link. So where looking at the distance matrix, we can find P1 and P4 are at distance 5, not within the threshold. Also, P2, P4 are at a distance 6. That is not within the threshold. So that will remain as such. When we increase the distance 5 again, the clusters will remain as such. We can't merge. So still there are 2 clusters here. When we increase the distance 6, yes, these points P1, P2 are within the threshold level, say distance 6 with these 2 points in a different cluster. So when the distance measure is 6, it's possible to merge these 2 clusters. So finally, using complete link, we can merge all the clusters as a single cluster only at the distance measure of say 6. So this is the difference between a single link and complete link. And this is the dendrogram representing the complete link. So at a distance measure 1, we are able to merge P1 and P2. At a distance measure say 3, we are able to merge P3 and P4. And at a distance measure 6, we are able to merge these 2 clusters. In this video, we have learnt about hierarchical clustering. Thank you.